Pambasuka tena, tuanze kusoma tena. Mafanikio kwa masomo yetu, dai bidii zetu. Hello, my viewers and my learners. Good morning, good afternoon, good evening, wherever you are. Welcome to Menya School. This is a math lesson on graphs. Graph is one way of representing information from a corrected set of data. The graphs can be in at this level, pupils, candidates are supposed to know on how to answer graphs of three types. One is the bar graphs. Bar graphs. Two, line graphs. And three, what we call travel graphs. In all these, the most important thing that a candidate is supposed to know is on the scale of the graph. A graph is drawn on graph papers, and usually a graph paper has small and big squares. So the big square in a graph measures 1 centimeter. A big square in a graph, it measures 1 centimeter by 1 centimeter. So that is one thing that a candidate must know. There are also smaller squares. There are also small squares within that big square, like this graph of mine here. The small squares are 1, 2, 3, 4, 5 within a big square which measures 1 centimeter. 1 centimeter. 1 centimeter by 1 centimeter. So all the three types of graphs are drawn on graph papers. The scale goes like this. We have two scales in a graph, and there is one that is what we call the vertical scale. The vertical scale, and also we have what we call the horizontal scale. So vertical scale and horizontal scale. Let me take, for example, my graph here. The vertical scale represents here the number of people. So what is the scale in this vertical scale? From 0 to the line of where my 1 centimeter ends, which is now the big square, it is 0 and 10, which means 1 centimeter represents 10 people. And the scale now is increasing by 10 all the way. So 0, 10, so 1 centimeter represents 10 centimeters. There were 10 people. 10, from 10 we go to 20, 30, 40, 50, 60. So that vertical scale is 1 centimeter represents 10 people. Now the horizontal scale is the scale that lands. So this is the vertical scale. It lands all that up. The horizontal scale lands this way. So the horizontal scale represents the number of days. The number of days. So the number of days, 1 centimeter. So here, the horizontal scale is representing number of days. So the days of the week, that is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Actually, the title of this happens to be a paragraph. The paragraph below shows a number of people who attended Masai Mara Game Reserve in 6 days. Use it to answer the questions that follow. So the title of this graph is that it is a bar graph drawn over data collected for a period of 6 days of the number of people who visited Masai Mara. So from here, a bar graph is drawn as the one shown here. Now, candidates may be required to answer several questions from such a paragraph. Like this one is asking, what is the average number of people who attended the game back in 6 days? What is the average number of people who attended the game park in 6 days? So average means you get the total number of people who attended the whole of 6 days and then divide by the number of days. For example, on Monday, 30 people attended Masai Mara Game Reserve. Tuesday, 25 people attended. Wednesday, 40 people attended. Thursday, 35 people attended. Friday, 50 people attended. Saturday, 60 people attended. So the total of these people will come to 25 plus 30 will give me 55. 55 plus 40 is giving me 95. 95 plus 85. That's I've summed to get the 35 and 50. So it's giving me 85. So 85, this is 0, carry 1. So 1 plus 9, give me 10, 180 plus the last one, 60. People who attended on Saturday, it's giving me 240. So the average will be given as the total number of people attended, over the number of days. So the total has come to 240, divide by 60, and eventually it's giving me, divide by 60. So this one will divide 6, 10, 6, 4, 6 days, 6 days, 6 divides here, 240, 40. That will give me 40 as the average number of people who attended Masai Game Reserve for the period of 40, for the period of 60 days. So that is on average. Every day, on average, Masai Mara received 40 people, 40 visitors onto that game reserve. Now, this is normally a question which nowadays comes as the last question in every paper. With me here is an assortment of some papers that I've collected in a folder, and I want us to look at some of these examples on various types of graphs. This is a travel graph. You can look at this one here. This is one other example of the travel graph. The question reads, the graph below represents a motorist's journey from town Q to town R and back. Q to R, somebody has traveled from town Q, he has gone to town R up there, and is coming back. This is an example of a travel graph. In a travel graph. So the other graph that I've just dealt with, I didn't mention it. This is a bar graph. This is a bar in the bar graph, in the bar graph. Okay, so let's come to this travel graph. So a travel graph, therefore, as we have seen, it's a graph which shows some traveling. Like this one here, we are told it's a motorist. That is motorist, somebody who's driving a car from one town to another. So we are asked, what was the average? The question is asking, what was the average speed from town R to town Q? So average speed is given by total distance traveled over total time taken. Okay, now let's start by looking at the scale. Even if this question does not indicate, or anyway, the type of graph that is drawn here, we can deduce the scale by assuming that what has been drawn here is on a graph paper. And let's start with the vertical scale. The vertical scale is indicating the distance in kilometers. This is a distance in kilometers. The horizontal scale is time taken. So the vertical scale here is from 0 to 50. Let me assume that is a measurement of 1 centimeter. So we can say the vertical scale is 1 centimeter represents 50 kilometers. So you see now 50 kilometers is going up from 0 to 50, 50 to 100, 100 to 150, to 150 to 200, 200 to 250, 300, 250 to 300, 350, 300 to 350, and up to 400. Now the horizontal scale is actually 1 centimeter represents 1 hour. So in order for us to know the total distance, distance of this motorist, we look at how far he traveled. So he traveled all this way, he rested somewhere here, went up, and they covered one-way distance of 400 kilometers here. Then after doing his business up there at town R, he decided to come back very fast. He never rested anywhere. And then he reached back at town Q at 2 p.m. So the total distance this motorist covered going was 400 kilometers. 400 kilometers plus 400 kilometers going and coming back. That gives you a total of 800 kilometers. Total time. So we have noted that 1 centimeter now, 1 centimeter will represent 1 hour. So 6 a.m. to 7 a.m. 6 a.m. to 7 a.m. is 1 hour. So this is 1 hour, 1 hour. Let's count the number of hours. 1, 2, 3, 4, 5, 6, 7, 8. 8 hours. So the total time it took to and fro is 8 hours. So therefore it will be 800 kilometers divided by 8 hours. 8 hours. So eventually this 8 goes to 800 100 times. So its average speed will be 100 kilometers per hour. You see how it goes. Thank you for watching. Thank you for listening. Subscribe to this channel as we be tackling more examples of graph questions from my assortment of these so many papers in my folder here. And then finally we'll as time goes by, we'll finally go to the KCP past papers and see what type of questions that appear in form of graphs. Thank you for watching. Subscribe now for more videos on maths lessons. Thank you.